Good morning, guys. Today we are going to learn a coding problem named Pascal triangle. So, how can we solve this problem? So, let me know the question first. In order to solve the Pascal triangle question, so first of all, we have to know how the Pascal triangle is formed. So, let me know. There is every row starts with 1 and ends with 1, and you have to know the two properties of a Pascal triangle. 3 and then 1 1 4 6 4 1 1 5 10 10 5 and 1. So this is about Pascal triangle. You know how this triangle is formed. Let me just explain you. Every row and every row starts with 1 and ends with 1, and this number is formed to according to the addition of the previous element of the previous row and the present element of the previous row. Means ith element in a present row is equal to ith element in a previous row plus I minus 1th element in a previous row. That's the logic here. And also, how can you solve this approach? So let me take a list. So see here, I'll simply take a list of array list integer and store each row in that integers in the array list. So if given number of rows double equal to 0, then automatically return empty list. Otherwise, take a new list and add a first row 1 and add a result set. And now if number of rows is equal to 1, then simply return this result and then start it from second row onwards. For int I is equal to 1, I less than. How can we get? First of all, we have to add 1 to a first row first element. So that's like I had it, and then I take a loop and I want to edit addition of previous rows. So row dot add of previous row dot get of j plus previous row dot get of j plus 1. Once this for loop is stopped, we have to add to a row and then return the result. The time complexity is O of n square and space complexity is O of n square. Now another thing is why this Pascal's triangle is useful. This Pascal's triangle is useful in the case of binomial expansions. For example, a plus b whole power is equal to, it's like c. When you add these numbers, we get the powers of 2. How we can get the powers of 2? 2 power 0, 2 power 1, 2 power 2, and so on. And next, it is also useful in binomial expansions. A plus b whole power 0 is equal to 1, and so on. And next thing, it's also useful in the case of generating a Fibonacci series. How this Fibonacci series is useful? When we sum up the diagonal elements of all the Pascal's triangle, then we get the Fibonacci series sequence. And another combination is NCR is equal to n factorial by r factorial into n minus r factorial. Instead of simply, if you can generate the Pascal triangle, it's n resembles the row number and r resembles the column number, 0 based indexing, then we can easily get an NCR problem. So it is also used to generate the perfect squares also. So this is about the Pascal triangle. I hope you like it, and please share and subscribe.